All right, so I heard, what did y'all say? There's not a 7. 5 and 6. Number 5. Y equals, which we could say f of x, remember, x plus 2, x minus 3. Some of these went off the page, and that is okay. What is the form here? Intercept. It gives you the places where it crosses the x-axis, right? So for this one, tell me where it's crossing. -2 and +3. Now I just need to find the vertex. To find the vertex here, I'm going to average these two together. So 3 minus 2 is 1 over 2. That's my x. That is my axis of symmetry. So when I find my y, here's where it gets sticky. I'm plugging this fraction in to this equation. Now I want to show you a little trick. If you already know how to do this and you feel good about it, you do not have to do this, but I would like to show you. I was talking to calculus about this morning. I did talk to y'all about STOW. Get out your calculator for a second. The STOW function. STOW, S-T-O? Oh, my Lord. I do this a lot if I'm dealing with a negative number or I'm dealing with a fraction that I just don't want to do a lot with. If you put in the value that you're subbing in this case it's what, 1/2? Every fraction goes in parentheses, remember. So I'm going to do parentheses, 1 divided by 2, close my parentheses. Now, you see that little button above the on button that says STO? Anybody ever showed y'all this before? Okay. If you hit that button, you get a little arrow, and then you're going to hit the X button right beside alpha. Hit enter. That tells me every time I type X, it's reading it as a half. So now, when I want to plug a half into my equation, I can literally just type the equation in. So remember, fractions go in parentheses. So -1 divided by 3, close your parentheses, parentheses x plus 2, parentheses x minus 3, close parentheses. I just typed the equation there that I'm plugging into. Hit enter, and it's plugged it in for me. If you go math, enter, it will put it into a fraction for you. I don't know if that's helpful for you or not. I'd rather not deal with all those fractions myself, though. Y'all don't look too impressed. Okay. STO, so type whatever you want X to be. If I want X to be 5, type X, STO, and then hit the X button and hit enter. And now every time I type X, if I do 2X, I should get what? 10. Whatever, every time you type it. So yeah. Math, enter. Will turn you into a fraction. All right, so the point of this, 2.083, somewhere around there, 2.083, right? So on here, I'm going up a little past 2. It doesn't have to be exact. I do need that value as I find my domain and range. If you haven't noticed yet, your range is always based on your vertex space. What's the domain? Negative infinity to infinity. In fact, nobody better miss the domain on their quiz because the domain is always. For parabolas, yes. For the quiz. I do part credit. How about the range? Lowest it goes is what? Stop it. Negative infinity up to what? 2.083 or 25 over 12 bracket because it always gets a bracket because that's a point on the graph. Good job. All right, and then number 6. Y equals 3x minus 3. Again, y'all don't like intercept form? Or you don't like it whenever it's an odd fraction? No. -2 and 3. Same thing, the axis of symmetry is a half. All right, where's your vertex? Guys, I don't mind working these, but I already know how to work them. So if I'm standing up here working them, it's not for my benefit. It is for yours. If I plug in 1/2 here, what do you get for the y value? Again, you can do the calculator if you want to. You can do it by hand. It doesn't matter to me. X minus 3. I'm not going that far down. I'm going to do this because I'm lazy. This is 1/2 -18. If you don't go all the way down because it doesn't fit, make sure you label that point so that we can tell where it is you're going and what it should be. What is my domain? Grayson, what's my domain? Yes, -infinity to infinity. What's the range? They're supposed to say anything. Calculus was fussing this morning because I don't hand them candy when they. This is the first year I've had them. The next year, we'll never have you again. I bring y'all in treats for breakfast a lot. I'll bring in like metaphors and stuff a lot of times for y'all. That's what I have to let you think. Your sleep. That includes factoring. Actually, I should say not just that component, but quadratics especially. So factoring should be second nature to you by the time you leave here. If you don't remember how to factor, it is a-okay because I'm fixing to show you. You know, the good news is we're done with graphing for this unit. Yay! Let me get so I get some good factorable problems here. I do not know how your teacher before taught you to factor. Do y'all remember how to factor? Okay. I'm going to teach you my way because my way always works. I like ways that always work, even though in some situations they're a little bit harder and in other situations that make life easier. If they always work, for me, it's easier to learn one way and be done with it. I mean, you don't have to learn all these to go, oh, should I use it now or should I use this now? So you always know. So I factor by grouping, and I hope that that's how teachers are teaching factoring these days. But if not, well, then they need to get on board. Before we talk about factoring, though, I need to run over a little something else, and that is GCF. Yeah. Factoring is the backward spoiling. Yeah. What's a GCF? Greatest common factor. And this is a single monomial. Monomial means what? One. Single monomial term. So it's the biggest thing that you could divide everybody by. If you can take a GCF out, you can factor. The way I'm going to teach you just does GCF over and over and over and over again. So let me give you a couple of terms. What would the GCF be of those 3 terms? Bigger still. 2 what? 2x, right? Because they all have an x to give. So here, go away, my GCF would be 2x. If these were set up in a situation to where I am adding them and I said factor out the GCF, how do you do that? That's right. What we're doing is the backwards of distributing here. So distributing multiplies, so the backwards of that is dividing, right? So I'm thinking if I had distributed 2x to all of this, what did I start with? Well, that means I started with x squared plus, what would this one be? 5x plus 4. Is everybody okay at a very minimum of taking out a GCF? A single one-term GCF. Okay. So that's going to be your first step. And I have, if you want it, I mean, you don't have to use it, but I have a little cheat sheet for factor by grouping. I'm going to go over all these steps. It's what I use whenever I used to teach CPOs. This links up in Canvas. Want it, you most certainly may have it. If you would like me to print you one, I'll be happy to. But we're going to run through those steps as we factor, okay? And I've got to talk quick because I didn't realize what time it was. All right, I'm going to start with an example, and I'm going to run you through the steps. And I think when you see this, you'll go, oh, yeah, my teacher did teach me that. Or you'll go, oh, wait, they taught me a different way, but this seems a lot easier. Once you get this, it is okay. All right, so my very first step, I'm always going to look for, and I say look for because every one of them does not have it, but I'm going to look for a GCF to factor out. In the case of this one, what is the GCF? 2x, right? They're all divisible by 2. Oh, not 2x, just 2. They're all divisible by 2, but this one doesn't have an x to give. So if you take that out, what is left? 6x plus, 6x squared, plus 7x plus 2. Is everybody okay with that? All I did was divide everybody by 2. All right, here comes the factor part. Do y'all remember factoring? Okay. I'm just going to look at this, what's in parentheses. It's a puzzle. If you can work the puzzle, it's easy to figure out. I'm going to multiply the first and the last together, and what do you get? 12x squared. Here's the puzzle part. I need two terms that multiply to 12x squared, but they have to add up to 7x, whatever's in the middle. So maybe you get confused and we start saying, okay, well, let's list all the things that multiply out to 12x squared. 3 and 4. What else? 1 and 12. But they've got to be x squared, so I'm putting an x on both of them. 6 and 2, right? Now, with that, they could also be negative 3x, negative 4x, negative 1x, negative 12x, negative 6x, negative 2x. Any of those would work to multiply to 12x squared. Agreed? So if I come in now and I throw a plus in the middle of each one of these, which one would give me 7x? That's the piece of the puzzle I need, okay? If you can do that, the factoring from there is all right? Here's what I'm going to do. Remember, this is backwards of foiling, right? Remember your foiling steps, how you start out with them here and then you end up getting bigger and getting... We're going to do that, but we're going to go the opposite way. So we're going to go from the bottom up. So here, I'm going to rewrite 7x as 3x plus 4x. I'm not changing the value, I'm just writing it a different way. So 2, I've got 6x squared plus the order does not matter here. Am I confused? I'm good. Oh, okay. That's still coming from here. The ends are the same. I'm literally changing my mind about what I'm doing. Separate problems, okay? So stay with me. I'm going to do what I always call this the slash step. I'm going to cut, and I'm just looking at what's in parentheses. Ignore that 2. That 2 is just going to follow me down all the way. I'm going to cut this problem in half. So I'm going to slash it. And here's what I'm going to do. I'm going to look at each half as its own problem, and I'm going to find the GCF of each of those halves. Okay. Now I got this little 2. This guy's just going to follow me on down. But what is the GCF of just the first 2? 3x. If I take a 3x out of those 2, what's left? 2x plus 1. Does everybody agree? If I distributed that through, I'm back up where I started. Everybody okay? The middle sign always stays. You bring it down. What is the GCF of 4x and 2? 2. If I take that out, what's left? Anybody confused about where any of those values came from? What do you notice? What is special? See. You see that in there twice, exactly the same? You know how we took a GCF out before and it was just a number? What if I take out a GCF but it's a whole chunk? You see what I'm saying? What if I factor out 2x plus 1 as the GCF? 2 stays, it just follows down. Well, I'm not going to square it because I'm going to take it out of both of them. So I'm going to write that 2x plus 1 just one time. And if it's gone, what's my last factor leave me with? Yes. Have any of your teachers taught you by this method? I hear yes and I hear no. Okay. Huh? No, because if you think about it, if I had, let's say I had 2x plus, let's say 2x squared plus 3x, and I took an x out of that, right? Even though I'm taking it out of, I could write this as 2x times x plus 3 times x. Even though I'm taking it out of both of them, I only write it once. So it's the same kind of concept. I'm taking it out of both of them, but if I were to go backwards and to distribute this whole chunk through, I would end up back where I was up here. Does that make sense? I'm taking my GCF is a whole big piece instead of just one little thing. I'm not big on pushing things to the bell and moving you things over things to be confused about. So what I would like for you to do. Now, let me get the paper that's coming to you has a step-by-step of the example that we just worked, okay? The steps are listed to the side, the example of it here, and there are some tips listed at the bottom of this paper to help you in factoring. Now, before I get to those tips, let me just say, if this middle sign, remember how I told you this middle sign drops down? If that middle sign is ever a negative, okay? This is not on the sheet. Then it changes the last sign, because essentially what you're doing is factoring out a negative. Okay? So on the back of this sheet, there are a total of 4 problems, just 4. I want you to try those 4. I understand you may or may not get them. If you did not learn factoring in your previous class, then you may not. If you did, then you may remember. But I want you to at least try them, because when we come in tomorrow, this is where we'll springboard from, okay? Remember things like If you multiply to a negative number here, what does that mean about your factors? That's exactly right. Does everybody hear that? Y'all are starting to get Sunday school feet on me, but listen. If I needed it to be negative 12x squared, what factors multiply to negative 12x squared? Negative 2 and positive 6, or, there you go, that's right. See, one of them has to be positive and one of them has to be negative, and that's what's going to throw you. So be very careful, but also remember that if I'm multiplying to a positive, both of them could also be negative. So that's where the tricky part in factoring comes in.